and good almost afternoon. I know you guys could be in the lunch line right now, so glad to see you all. Today we're going to talk about the migration trifecta, how to move fast, shift budget, and deploy AI. I'm Eyvonne Sharp, and I lead our North American infrastructure team, customer engineers that focus on all things infrastructure. And here with me today is also Jeff Welch, who's a principal in our product management team. So let's dive in. When we're looking at infrastructure, one of the challenges that we face is that our traditional infrastructure in our current environments wasn't built for the demands of AI. So we have a gap between what we have today and our goals and the capabilities that we need in the future. So we have data silos, we have vendor lock-in, and we need to be able to move faster. So today we're going to talk about how we can do that. So let's do a bit of a reality check and talk about why do we need to do this now? Why should we prioritize migrating our workloads? And it's because AI is offering new opportunities for innovation, but 70% of our data is locked up in silos, it's on premises, and we're having a hard time accessing that data with our powerful AI systems. So to meet this goal, we need to unlock that data, and it needs to be available with high performance and low latency to enable enterprise scale. But I said a magic word there. Latency is a challenge. Often we think bandwidth is our limiting factor, but it can be latency, and that is the amount of time it takes, which is really defined by distance. With all of our technological innovations, we still haven't solved the speed of light problem that causes our latency. So this determines how quickly we can fill the pipe, and really distance. Shortening that distance is the only way to do that. So high latency becomes like an ROI tax. So we need our workloads co-located with our powerful AI systems, and that is going to help us drive innovation in our environments. So how do we address this? First, we have to shorten that distance, and co-locating our workloads near high-performant AI systems is the best way to do that. It gives us optimal application response times and helps us improve all of our system performance. But this isn't just a move. It's an infrastructure upgrade that's going to help us build the foundation for AI readiness as we go forward. So let's dive in to talk about our migration approach. So Google has a 4-step methodology that really involves assessing, planning, migrating, and then innovating. So to assess, we have our free Migration Center tools that are part of Google Cloud that are built in that you can download and deploy in your environment. It's going to assess your workloads, help you understand what you have so that you can make a plan to migrate those workloads. It's an easy tool to deploy in your environment, and it'll provide you the information you need. Then the next step is to plan. So we have to map what we learn in that assessment process to plan where those workloads are going to land and live in Google Cloud. This is a critical step, and we're going to talk today about some of those landing spots for your workloads, and really how we have an option no matter what you're doing today. Then, of course, it's time to migrate. So we have migration tools that are built into Migration Center to help you migrate those workloads. We have guidance and expertise, and we're going to talk about some of that today. And then, of course, it's time to innovate. So we're going to round out this talk today with a demo that is going to demonstrate how you can use AI right in the cloud console to prototype applications and to rapidly build and understand what you need to do in your environment. So next, Jeff is going to come and talk to you a little bit more about the assessment process.
Everybody, it's great to be here today. My name is Jeff Welsch. I'm a principal in our product management organization for the AI computing group. So in our group, we have all the TPUs, GPUs, but also the standard computing for virtual machine families, block storage. We have the consumption models for GKE, Cloud Run, et cetera. So largely, it's the infrastructure and ways to consume those infrastructure services in our team. I specifically also am involved heavily in our migration efforts, and I'm here to talk to you today a bit about some of the tooling that we have today. So first, Eyvonne mentioned Migration Center. I want to talk a bit about that. So she mentioned the concept of deploying some assets on a source environment to discover workloads and resources, which is absolutely something we do. But Migration Center is also, it's our first party free tool and service that's embedded in the console to help you analyze that data that comes from that discovery client and other sources of information such as RV tools from VMware or cost and usage reports from other cloud providers as well. This is that unified data platform that can help you understand the cost to move to the cloud and help you understand and make decisions about, say, mapping sources to destinations in terms of capacity and so on and so forth. Recently, we've launched some new capabilities for Migration Center that really help you understand the total cost of ownership more accurately. So if you wanted to, for example, now we help you model out your costs over a 5-year forecasted migration process or period there. We're supporting more billing receipts from some of our comparable clouds to help you analyze your consumption on those environments, and you can work with your account teams to have access to these types of reports. And we continue to improve the capabilities that we offer from a technical assessment perspective. So when you use Migration Center, we're going to provide insights into the latest compute families to help you understand your migration strategies, as well as we're going to help you understand network modeling, network visualization, dependency mapping and such, as well as independent software vendors that might be deployed. So all this helps you understand and have an educated understanding of what the migration to Google Cloud might be like. Now, Migration Center as it is today is in the console, it's in Pantheon, and what I want to show to you is the first iteration of services that we are deploying using agents to help this migration process. So I'm going to go ahead and cut over to a live demo here, live dangerously only once. I'm going to do this a few times today, where we're going to talk about how we can start to see how AI can change the migration planning process. And I'll do another demo as well in the future. So the first iteration we have is really to understand if I have the most basic request, I want to understand what my costs might be on Google Cloud. The agentic Migration Center capabilities allow you to do this with very minimal information. So in this example, I'm going to create a quick estimate. I'm going to call this Next 2026. And this will create a new estimate with, again, just 4 pieces of information. It's a great way to start here. Say I have 1,000 VMs, maybe I'm moving over. There's 8,000 vCPUs across those, maybe 32,000 gigabytes of memory, 4 gigabytes per vCPU, and maybe 500 TIBs. I don't know, that TIB is still challenging for me. Right, with that information, I now can say, hey, maybe I'm going to accept the standards. I'm looking for general purpose compute. I want to start with the N4D. This is our latest AMD-based processor. And I'm going to use hyperdisk storage pools, which is a great way to really improve your operational model and the cost economics of block storage. But maybe I'm actually a customer or user on the East Coast, and I want to say, rather than be in the Central, I want to be on the East Coast. Maybe I make a small change there. With this information, I can create an estimate of what those costs might be moving to Google Cloud. So here you can see right out of the gate with just 4 pieces of information, I can identify that I can save approximately 15% on this amount of capacity that I've provisioned. I can tune this, I can edit this, et cetera. We have some other information here like technical breakdown and so on and so forth. But one question you might have is, how do I calculate those 15% savings? Are we just making up a number? And so this is where AI really starts to come into play, right? So we have this chat interface here today where we have some chips that help you get started on some questions here. And one of those is, how are my comparative on-premises costs calculated? So how do I know that what this 15% means? And I'm going to make this a little bit bigger to see the output here. And so what we're focused on here is when we build these agents, math is something that needs to be accurate for these calculations. And being clear about how we come to these calculations is also important. So now we've explained how we've calculated this, the hardware selection, the costs and assumptions that we're making here. which is very helpful. Now you maybe are a little bit more comfortable with where that 15% comes in, but you of course probably want to save more money. And another chip we have here is optimize this current estimate, right? And so this is going to have AI now look at some of the experiences that we've gained from our customers and also look at different cost profiles and identify opportunities to save additional money. So in this case, we can see that by changing from US East 1 to US Central 1, you could save some money. You could enable CPU benchmarking to right-size the virtual machines more appropriately. We have our experiences, many of our customers that move over actually end up, when they do an assessment, the result is about 10% of what they think they need to move turns out to be idle machines, so you can go ahead and make that assumption as well. And then you can maybe change your committed use discount and your consumption model. But as I said, I'm on the East Coast, so maybe I want to do something more and say optimize, let's do optimize my costs while staying on the, let's say, in an East region. Right, because I'm interested in, as Eyvonne just educated us, I understand the importance of latency. I want to be close to my users, right? And so now I can ask AI, or Gemini here in this case, to help me optimize those costs while maintaining that restriction here. And as this comes back very shortly, there we go. Now I see that I can actually move to the East 4 region and still save comparable numbers, right? And so with this data and by using this information, I can actually apply all this data here, apply the East Coast plan, and you'll see my savings have been changed to 39%. So there's many more things you can do here. We're adding more and more refinements and capabilities for data as input, et cetera. You can imagine this is kind of an undefined journey in the future where you're bringing your information to add more context that can help refine these cost estimates. So that's the first iteration. This is moving into preview as well. Please, there's a QR code at the end where you can sign up for some information from your sales teams as well to learn more about this. So that's the demo here. I think we're going to now pass this back to Eyvonne. Thank you, and talk to you shortly.
All right, so let's talk a little bit more about the planning process that we need to undergo. This is a bit of an eye chart, I realize, but the point of this slide is that there are many paths and homes for your workloads on Google Cloud. Whether your VMs are running in a VMware solution, Nutanix, whether your workloads are bare metal, whether they're in containers, or regardless of the data platform, we have a place in Google Cloud to run your workloads, allowing you to unify everything so that you reduce your overhead and that you can be more efficient, not only with your resources, but with your people. We're not going to cover all of these options today, but we are going to dig into a few of them. First, let's talk about VMware. So, especially for small organizations, they have a lot of deep expertise surrounding the VMware solution. It's what they've deployed in for years, and they have operational systems that are based around that technical framework. So, this kind of migration from VMware on-premises or in another cloud to GCVE, which is Google Cloud VMware Engine, provides a like-for-like experience so that your people, your IT staff, are using the same operational processes that they're already using. So it allows you to migrate more rapidly. They can use the HCX tooling inside of VMware to accelerate the migration. They don't have to learn anything new. You configure your connectivity, and they work in many ways the way that they always have. So this is a great option for folks that have a lot of VMware expertise in their environment. Now, let's talk a little bit about data migrations. So we know that if you want to implement AI, your data is critical. And so if you have on-premises data workloads, whether those are Microsoft SQL, whether they're MySQL, or whether they're Postgres, you can deploy those workloads in Cloud SQL and deploy them in a fully managed environment, remove the effort and overhead of managing those environments. We have our database migration service that will make that process simpler for you. And of course, if you have transactional or analytical workloads in Postgres, we have our AlloyDB offering. Again, you can use that database migration service and get the performance that you need for your Postgres workloads. So that is also an option for you. And of course, if you're running VMs in those other cloud providers, we can run those on Google Cloud as well. You deploy Migration Center, and it's going to provide a seamless tool to help you migrate those workloads from where they are to Google Cloud. And know that our compute offerings are vast. So we have standard compute nodes. We also have memory optimized, storage optimized, compute optimized nodes, and we have custom machine types that allow you to configure the resources, compute resources on your virtual machines to get absolutely the performance you need without having to pay for resources that you aren't already using. And our last technology that we're going to talk about here today is hybrid subnets. So this was built directly with our customers for companies that need IP portability. In other words, they need to keep the IP address on their VM while they migrate it to Google Cloud and run it on our native compute engine technology. So hybrid subnets, again, like our engineering teams, this was a need that emerged from our customers. We worked directly with them, and it's a capability that's going to allow you to migrate those workloads. I know IP addresses should not be the sticking point, but in so many of our environments with workloads that have been there for a while, it's the level of effort to change those IP addresses is so high that it becomes a barrier. So this is a great tool for that as well. And now we are going to go back to Jeff and talk about the actual migration.
Thank you, Eyvonne. Migration is great. It's a great way to get your data there to start a lot of innovation, but there's also opportunity to modernize during the migration as well. Specifically around infrastructure. When you're moving from one location to another, the migration event is that opportunity to optimize your infrastructure for deployment on Google Cloud. So we see customers that are interested in fine-tuning their environments and to make sure they're not lifting and shifting, say, the sins of an old source environment right to a new cloud, right? They want to clean up some technical debt. And so we see customers that are interested in re-architecting into optimal GCP solutions, specifically around infrastructure as a services, network security policies, identity and access management. All of these topics are an opportune time during a migration to address. But we also see customers who are, particularly those migrating from an on-premises environment, quite interested in migrating their operational stance into more of a DevOps or infrastructure as code-focused deployment as well. So this modernization is possible during migration. Now, if you look at what we experience, and maybe some of you have as well, that migration journey, the time period required to perform the migration, it can be extensive, right? And then if you look at how we, in our experience, break down the time where you spend working for a migration to complete, a large chunk of that time, if not the majority, is really spent in that designing of the modern infrastructure, of understanding how to optimally deploy infrastructure as a service resources on Google Cloud, and then how to implement that with Terraform. So if we look at this time period, that's an area where we think we can help accelerate the process. So what I want to show now is another live demo, if we can go ahead and cut over there, of what we're working on to accelerate and dramatically reduce that time period spent on designing for the future state. So what I have here is what we're calling a migration planner, right? This is coming soon. And I've got kind of a pre-baked version as well in here, but I'm going to start with a new plan. In this example, we're not looking at an estimate, we're looking at maybe what is my migration plan itself. So I'm going to call this also next 2026. And I've got, I think that's going to show, yes, I have a small Terraform representation of, sorry, I got to do some authorization here, of an environment on a source cloud actually coming from Amazon, where we have used a product we have called Terraformer that allows us to inspect any API with a Terraform provider and convert that to accurate Terraform. We can represent the source environment as Terraform, which then can be used as input for this migration planner. So now we're processing the structured data in this regard, right? And then AI is going to help understand what the environment is. So with this migration planner, we can see I've imported the Terraform, and now I know, okay, this is an AWS environment. It's running a Kubernetes cluster. It's running that on Amazon EKS. I've got some host names, et cetera, and a summary of resources. This is a great way. It's similar to like using AI to understand your code base. You can now understand your infrastructure as a service deployment. On top of this, we have a tree representation of all the resources that are there so you can validate this. But trees and data is not the goal. We also help you visualize this information, right? So now you can have a visual representation of what the source environment is, which is very helpful if somebody happens to be inheriting something, for example. But we're not limited to just analysis. I can ask contextual questions, maybe something like, what is the compute used in the EKS cluster? Now AI can understand this code. It can start helping me answer questions about it. Now, this is, I think, a straightforward question where I could actually identify the C5 large instances by exploring that tree as well. So contextually, I might want to answer questions such as, how is IAM implemented? If I can type. Right, and so now Gemini is able to help us understand the details of the implementation and the implications of that configuration as well. Right, I have my cluster roles, et cetera. So this is helpful, but this big button here, generate GCP architecture, is ultimately where we're headed. Right, this is what we want to get to. We want to help that migration process. Now I'm going to cut over to that takes about 10 minutes in this example, so I'm going to go ahead and cut over to a pre-processed version that I've shared. And this is the output that you receive once that processing is done. Now you have a visual representation of what an equivalent architecture from that source would look like on Google Cloud. Now we have the similar capabilities here. I have the tree that I could explore the now Google resources for that deployment. Importantly, I have the Terraform generated or created to generate that environment. So I can download this, I can manually apply it, add it to a CI/CD pipeline, but I've automatically now created that infrastructure as a code capability for this migration, right? And I can deploy this and edit this in Terraform. There's some other keys that we focus on here. Let me make some more space here. The resource mapping tab tells you what decisions AI made. So for example, I have an AWS subnet that mapped to a Google Compute subnetwork, and it tells you why it made that decision, right? And so in this example, we've consolidated multiple AWS zonal subnets into a single Google regional subnet. Right, so now this is a kind of an audit log to understand why AI made decisions for you. What we're also doing, as I talked about the idea of modernizing and applying the optimal deployment of infrastructure as a service resources, we're applying best practices that we have defined in our product line. And we're applying these to the Terraform that we build. So for example, we have some recommendations for HA and resilience, right? We've moved from a zonal to a regional cluster. And we explain why this is an enhancement, right? So now you understand how we're actually, we believe, improving the target state architecture. And again, diagrams are great, as is the ability now to compare the source and the target, right? So now you can visually review, yes, okay, I see how that makes sense, right? And then, of course, we have the capability with now asking contextual questions between the source and destination. If we go back to how is IAM implemented on the target, and how does that compare to the source, right? And so now we have the ability for AI to help us understand in context of the source and target, right? So we can compare the environments and understand, again, why decisions were made, right? Let's scroll back up here. So this is the process we're working on, and we can cut back over to the slides here, to help dramatically reduce that time period, right, of the migration itself. And you can imagine infrastructure as code can be cut over. Oh, can we go back to the slides, please? Can be deployed, rapidly iterated on to help this migration process accelerate in time as well. I'm going to hand it back over to Eyvonne.
We assessed our environment, we've planned, we've used AI to help us with our migration. Now it's time for the fun part, which is why we're all here to innovate. Today I'm going to show you a pretty straightforward demo about how to prototype in Gemini CLI right inside the Cloud Console. I will show this slide again so you can grab that QR code later if you need to. But like all good demos, This one is going to start in the Cloud Console. And so what you're going to see us do here is we're going to go and we're going to launch the Cloud Shell, that wonderful unifying Linux environment that makes all of our services in Google Cloud accessible to us. So what we're going to do here is we're going to clone that GitHub repo that I will share you the link to. And once we do that, we're going to launch Gemini CLI right inside of our Cloud Console. It's there and available to everyone. So once we launch this, we have a couple of slash commands available to us that are defined in what are called TOML files, and those are plain text definitions of how these commands need to work. And so what we're going to say is we are going to issue the idea to spec command, and we are going to say, build me a web app, and I want it to track all of my infrastructure changes. I want to include the date, system name, and relevant information. And so Gemini CLI is going to come back and define that spec for us. We're going to get a high-level summary. We're going to define our target audience, core features, a technical stack recommendation for what it's going to build. It's going to define our data model, our user flow, and then it's also going to define what's out of scope for this project. So now we've done our spec-based development, we have our spec written, and we are going to run the slash command that we downloaded called spec to code. Again, this is all defined in plain text, and so we're going to take that spec that Gemini CLI just helped us build, and we're going to start deploying code. And you see, it prompted us a second ago for permission to start creating a folder. It's going to write the code. We're going to see it continue to think, and we're going to see it write Python code, which is what was defined in our spec. It's going to create our data model, and it's going to deploy all of that in a folder that we gave it permission to create in our Cloud Console. So it's continuing to think. We're going to see that HTML code scroll by because we told it we were building a web app. And then it's going to write a README Markdown file, which is going to work as our documentation for this app that Gemini is building. And it's going to provide for us instructions on how to build, deploy, and launch this app. So you see here, I'm going to open up a different tab just to make it easy to see what we're doing, and I'm going to start pasting in the commands that Gemini gave us in its documentation. So what you're going to see, in this tab is that we're going to do a pip install on our requirements. We're going to load those. We're going to see those run and install, and then we're going to launch our app. And right here in our Cloud Console, we're going to get a link to launch that app. So we're going to click that. It's going to open a tab, and here is our infrastructure tracker that we asked Gemini CLI to build for us. Zero code written, just text-based definitions for what we want to do. You'll see also that it created a couple sample entries. We didn't define what those needed to look like. It defined those itself. So now let's say we built this app and we want to refactor it a little bit. We want to use a different, like Google Materials design framework, and we want to use Google Cloud Colors because we're at Next. So it's going to do the refactor. We're going to see it do a little bit more thinking. We've already given it permission. So it's going to go and show us the diff between what we had, what the new code is, and it's going to deploy that in our environment. So again, we're seeing the updates scroll by here. And remember, we just made plain text requests to refactor our app. So we're going to get a summary of what it did. We're going to switch over to our tab. We're going to refresh, and we're going to see a new UI that we told it to build. Again, I didn't give it the hex codes for Google Cloud Colors. I didn't tell it what those were. It knew. It kept all the existing functionality that we had. All the data was there, and refactored our app. So you can see the power for your teams. As you you want to try something out, and instead of talking about what it could look like or what your idea is, you just go build a prototype. And you've got it there, you can play around with it, and you can have some conversations about what that needs to look like. And so it's good. And then, because you're using spec-based development, you have this very well-written, clear spec that your teams can use to refer to as they continue to build and innovate. So one of the things I want to point out is in this GitHub repository, not only is there the definitions for this demo, there are some great tools in there to help you migrate your workloads. Not only some documentation, but some tools to help you dive in that we just didn't have time to cover here today. So, with all of that being said, it's time to wrap up. So what we've talked about, we have a structured methodology to help you migrate that includes assessment, planning, migration, and then innovation. In addition, I want to point you to some of our funding programs that we have to help you along the way. And then, of course, if you need to move any faster, we have support from professional services and partners who can help. So we've recently revamped our Google Cloud Ramp program, and this is our program for customers to help you not only migrate, but to move faster. So if you Google Cloud Ramp, you will find information about this program where we have prescriptive frameworks, we have governance guidance, we have a vast partner ecosystem of partners who are enabled training, tooling and runbooks, and also funding and incentives that are milestone-based. So as you deploy workloads, you're going to get more resources to help you deploy even faster. So please check out the RAMP program. In addition, we have free assessment tools. I'll give you a minute to grab those QR codes if you'd like, and a free consultation. So pull those up, use those resources that we have available to you to help you along your journey. And while you're here at Next, there are other sessions and events available to you to help you along the way. So please check out those.